welcome to my YouTube channel. This is the second part of a linear function where I'm going to teach you how to sketch a graph, how to determine the equation of a linear function using a graph, and how to write down the domain and a range of a function. On the previous video, we're supposed to sketch a function f of x equals 2x minus 6, where we managed to calculate the x-intercept and the y-intercept, and we got 3 and 0 for the x-intercept, and then we got 0 and negative 6 on the y-intercept. Now, how do we sketch the function? Like I told you that you must have the x-intercept and the y-intercept, and then from there you must be able to tell whether the function is going to be increasing or decreasing by looking at the gradient. Our gradient is positive here, which means that the function will be increasing. An increasing function must look like this. It means that the line has to be going up when measured from the left to the right. As you can see that it's going up. So I'm going to draw my Cartesian plane here. Here's our Cartesian plane, y, x, and 0. Since we have our Cartesian plane, I'm going to write down my y-intercept and my x-intercept. What is the x-intercept? It's 3 and 0. Y is 0 anywhere on this line, and x is 0 anywhere on this line. So it means that our x-cut is at 3. So you are just going to choose a point where you're going to write your 3 there, depending on the numbering system that you are using. I'd say that 3 is somewhere here, and then y is negative 6. If I say this is 2, 4, 6, it means that my negative 6 is gonna be somewhere here. Then what you do next, you just need to connect these 2 points by a straight line. So I'm going to connect them like this. There we go. This is f of x. Then you are done. Let's take a look at another example before we jump into the next step of the linear function. Suppose you have the equation f of x equals negative 3x plus 12. And we are supposed to sketch this function. First of all, you must know that you must have the x-intercept, y-intercept, and know the polarity of the gradient. The x-intercept, we know that you must let y equals 0. So this is y equals negative 3x plus 12. You know that you must let y equals 0. This is x-intercept. So 0 equals negative 3x plus 12. Then you take negative 3x to the other side. And you know that whenever a certain variable jumps the equal sign, it changes its sign. So we are going to have positive 3x equals 12. And then we are looking for x. You divide both sides by 3. And then x is going to be equal 4. So the coordinate of the x-intercept is 4 and 0. What about the y-intercept? The y-intercept, you know that we look at the constant at the end of the equation, of which is c. So the equation says y equals mx plus c. When you compare this equation with this function, you can see that m is represented by -3 and then c is represented by 12. In other words, the y-intercept says y is equals 12 because we said this is the y-intercept. Okay? Now let's look at the gradient. The gradient is going to tell us whether the function will be increasing or decreasing. This is a negative gradient of which insinuates a decreasing function. How does a decreasing function look like? When we measure it from the left to the right, it has to be going down, meaning that it's gonna look like this. It's going down as we move from the left to the right. The line is going down. So now let's sketch our graph. First of all, what is the value of the y-intercept? Y-intercept is 12. If I say this is 3, 6, 9, 12, this is going to be 12 here. What about the x-intercept? It's 4. If I say this is 2, 4, it means that 4 is going to be somewhere here. And then what you need to do is to join these two lines using a straight line, just like this. But don't forget to use your ruler, because your line has to be straight. Then this is f of x. Another example, the last one. H of x equals -1/2 x minus 3. This is our example. Then what I'm gonna do now, I'm going to calculate the values of the x-intercept and the y-intercept. X-intercept, you know that you must let y equals 0. Y equals -1/2 x minus 3. And then we let y equals 0. Why am I doing mistakes? Minus 3. Then what are we going to do next? We are going to take -1/2x to the other side, which is going to be positive because it's going to jump here. So it's 1/2x equals -3. Then we divide both sides by 1/2. X is gonna be -6. So the coordinates of the x-intercepts are going to be -6 and 0. Y-intercept, you know that the last part of that equation represents c, of which is the y-intercept, meaning that -3 is the y-intercept. So the y-intercept is y equals -3. So the coordinates of the y-intercept 0 and -3. Now let's take a look at the gradient. The gradient is negative, as you can see, of which insinuates that the function is going to be decreasing. A decreasing function has to be going down when measured from the left to the right, just like this. It means that we expect to see something like this. Now let's sketch the graph. Y x. So what is the value of the y-intercept? It's -3. Negative is at the lower part of the Cartesian plane on the y-axis. If I say this is 1, 2, 3, it means this is going to be -3. and then x is negative 6, because this is 2, 4, 6. Let me say 2, 4, 6. This is going to be negative 6. Then what you do next is to join these 2 points. Just connect them like this. So this is h of x. Okay, let's move to the other part of linear function, where you are given a function or a graph and you are supposed to determine the equation of that function using a graph. For example, if you have a graph like this, this is y, this is x, and they say this is h of x. The coordinate of the y-intercept is 0 and 6, and then the x-intercept is negative 2 and 0. And they say h of x is equal mx plus k, and they want you to determine the values of m and k. First of all, just look at the graph. As you can see that this is an increasing function, because when we measure it from the left to the right, this line is going up. I believe that you already know that. And then how do we get the value of k? When you look at k, k is the y-intercept, like I have explained in the previous video, that the last part, or the constant, is the y-intercept. Now let's look at the y-intercept on this graph. When you look at this point, this is the y-intercept, of which is 0 and 6. What is y? Y is 6. It means that the value of k is equal to 6. In other words, k equals 6. So this equation is going to be f of x, or it's h of x, h of x equals mx plus 6. And then how do we get the value of m? Since we said this is an increasing function, it means that the gradient is going to be positive. So how do we calculate the gradient? In the previous video, I have explained how we can find this value. M is equal to y2 minus y1 divided by x2 minus x1. Remember that y2 minus y1, or x2 minus x1, you just decide which coordinate you want to name one, a coordinate 1 or coordinate 2. For example, this one. Let me say this is 1, and then this one is 2. It means that whenever I have to substitute the second coordinate, I'm going to pick it from this point, the first coordinate from this one. So I'm going to say y2 is on the second coordinate, of which is 6, minus y1 is 0, divided by x2, which is 0, minus x1, which is negative 2. This is going to give us positive 3. In other words, our equation is going to be h of x equals 3x plus 6. Okay, right now we're gonna be talking about a domain and a range. What is a domain? Domain are the values of x where a function is defined, and a range are the values of y where the function is defined. In other words, domain are the values of x where we can find our graph in a Cartesian plane, and a range are the values of y where we can find our graph on a Cartesian plane. Let's take a look at this graph. We want to determine the domain now. When you look at the negative x-axis, the graph is there. And when you look at the positive x-axis, the graph is still there. And this arrow and this one indicates that the function is continuing like this, meaning that it will be there for all values of x. When the function is defined for all values of x, we say x is the element of all real numbers, meaning that the domain of this function will be like this. What about the range? Let's take a look at the values of y. When you look at the negative y-axis, the function is there. And at the positive y-axis, it is still there, meaning that this function is defined for all values of y. In other words, it means that the range is gonna be like y is the element of all real numbers. Suppose you have a function like this, and they give you something like this, and they put a circle here, and then an arrow here, and then they say this point is -2 and 8. This point is 3. This is 6 maybe, x, and then they say determine the domain of this function and the range. Domain, range. When determining the domain, we just look at the values of x. When you look at this point, there is no arrow that indicates that this function is continuing like this. It means that it starts from that point going this side. So how do we write this? A domain. We look at the values of x. X is -2 at this point, meaning that from -2 going this side, our function is defined. But from this point going this side, it's not longer defined. It means that the value of x must be greater than the x value at this point. I mean the domain, we're going to say x is greater than this point because it is on the right hand side. When talking about greater and less, focusing at a certain point, when you go to the right, you say greater. When you go to the left, you say less. Let's look at this point. The x values or the function is only defined from this point going to the right, meaning that we are going to say greater. So how do we write the domain here? We are going to say x is greater than -2. With this point included, it means that we are going to say greater or equal to -2, because we also include this point where x is -2. What about the range? Looking at the y-axis vertically, when you look at this function from this point of which is 8 going up, the function is not defined. The function is only defined from this point going down, meaning that we are going to say less, because when it's below we say less, when it's above we say greater. When we are talking about the x-axis, when it's on the right we say greater, left, less. A sign that represents greater must look at the right, or must be pointing at the right. When we say less, we point at the left. So y is going to be less because it is below this point. Less or equal to this point of which is 8. I believe you're understanding something. If you don't understand this part, please let me know in the comment section so that I can explain more, or I will just make another video focusing on this part only, using many graphs